Okay. So good morning, guys, and welcome to the session. So basically, Sahil from placement team will talk to you for some time, and after that, only we'll start with the lecture.
Dhruv, you are from which location?
Right now I'm in Chandigarh, sir.
Ranjan? Sorry. Sorry. Vaishnavi? Mara is online. You guys are online?
Yes.
Who else? Who are from online?
Ranjan.
Lokit, you are from which location?
Sir, I am in Chiplun right now.
Okay. Who else? Amul. Amol. Amol? You are from which location? Siddharth is from Delhi. Who else?
Dhruv, which location are you from?
I'm in Chandigarh right now.
So I think so what I'm going to talk is about an opening which is in Pune and Mumbai. You see if it's been feasible, you can apply. I think guys, you have already gone through the WhatsApp when it comes to the opening which I shared for college.
No.
Actually,
So your voice is cutting.
Online student, this is regarding one opening, actually, specifically for those candidates who are located in Pune. The JD will be shared across with all of you by Sahil sir. So at the moment, he is just interacting with the classroom candidates. If you have any doubts after reading the JD, you can get in touch with the placement team.
Okay.
Ma'am, I wouldn't be eligible.
You are in Chandigarh, right?
Yeah, you are. You're willing to come.
Yeah, I can come.
For an interview also.
Yeah.
Sure, then you also can apply for the same.
Okay.
What about Mumbai, ma'am? Sir, we're talking about Mumbai.
Hello.
Just hold on, Amol.
Okay.
Online students, check the JD which has been shared on the group.
Okay, guys, just for your information, you can apply for
Hello? Ma'am? Sir?
Yes, Dhruv. Yes, Dhruv.
I wanted to ask you, will there be other job opportunities where the internship period wouldn't be there and I would directly get a job?
There would be, but we cannot commit you what is the deadline or timeline for those opportunities right now. So whatever you're getting right now, if in case the work profile is suitable, whatever you have learned, just go ahead with it.
Okay, ma'am.
Okay.
And will the interview be?
That details will be shared across with you on the WhatsApp group itself.
Okay, ma'am. And they don't provide housing or anything, right?
Allowances?
Housing?
Yeah, that means allowance, right?
Yes, ma'am.
That will, if in case they are, then they'll be committing to you during the interview itself, not right now.
Okay, ma'am. Ma'am? Hello?
Dhruv, 1 second.
Yeah.
Dhruv, yes, tell me.
If I don't get selected on the after the internship, will I still be eligible to get job opportunities from Imarticus?
Yes.
I would?
Yes.
Okay, okay.
But Ryan should not come back saying me that your behavior is not good.
No, okay, I understood.
Must be your performance.
Okay, sir. Thank you.
Deadline you have today. You can apply today. I will be sharing the profile on Monday. Actually, I was supposed to share the profile yesterday, but very less number of profiles. So I have to close 10 pages. So my suggestion to you would be internship is always good because it's local and you get that, internship में क्या होता है कि you will not get that kind of a pressure to perform or maybe that pressure to prove yourself, but yes, there is kind of a training period wherein companies not investing much in your attitude, in your dedication, in your discipline, all these factors. Plus whatever that training they see, how you have been grasping and being on. So after 3 months, you will be in a full time because while the company keeps this internship, they don't want to just invest in them. They are often individuals. So after 3 months, definitely will be kind of legal. If not evaluation, maybe all these things your behavior comes into place. So take a decision. तो तुम लोगों को सेकंड मंथ में पता लग जाएगा you are there or not. So you will be good. And if company is not been taking you forward, giving us a reason that your performance is not good, you have all the right to come back to the table and do what. Having said that, company should not come back saying that your behavior is not good, this is not good, something there is a weakness terms, then I will not be taking it. Because I can't take that risk of the company.
Apply. Those who are 2020 pass outs and above that 21, 22 apply.
What's your qualification license? BBA, technical, engineer, civil, mechanical, general.
Sir, there's an issue with my profile.
That is okay, but interview the very interview the wrong provided. We want to trading like interview question wrong. Interview में क्या है अपना प्रोड्यूस करना है जैसे बोलना है almost 31 lakh कर.
Did I take this? पूरे टाइम में
अभी इन ये जो लेवल पे नहीं है कि अगर इसे बोला जाए रेट तो नहीं होटल में तो वो सब क्या हो गई.
Why?
ठीक है ऐसा एक रैंडम नंबर करके करनी है और जो हाँ करनी है what कौन सा प्रोजेक्ट होता है जो बोले ना वो ये बात वो मार्केट वैल्यू एक टेक्निकल रिटर्न की तो निकाल लेते हैं तो लगता है बट वो जब इंटरव्यू में जब सामने वाला पूछेगा तो ये लोग
anybody among you is into an IT? No, right? So let's start with this.
So voice is not coming very clearly.
ग्रुप तुम ना ऑफलाइन हो जाओ बाद में बात करते
Okay, sir.
let's start with the starting with your name, your qualification, your family background, what currently you're doing, your hobbies. What is it? Yeah. And whatever extra you want to add, I would love to hear it. Anyone on that? I think fine. So when you are giving the introduction, ensure that you will not be saying that it was is going on. You have to say it completely, and you will not be willing to take it forward. The same courses. So I that I am under the please keep it simple. Don't say that you are running, you're going to your course, joining has to be completed. That's how getting to right. You get selected, definitely you will do something that will be certificate. The client says that there is no change to the CV to the passive because study. You have to change it. It's a priority. Okay. So this is something you have to do. So this is one. So line I understand one thing, this sequence that you is working on. Then what are the moves? What if I use it? I have Prathamesh Pradeep Joshi. I've completed I completed bachelor's in mechanical engineering. I have post-graduate in banking. I did the art of user and my system. And I like to play cricket and watching some innovative videos. So I completed some projects in learning, like times we are predicting the upcoming 12 months
Hello, sir. My name is Kalpit Khan. I am from Pune itself only. I have completed my mechanical engineering from MIT College of Engineering, and I have 2.5 years of experience in automobile sector as a quality engineer. And I have built projects on NLP, on Amazon data, and even linear regression on bank house prediction. And we are family of four, and my father is businessman, and I like to read and play chess. Myself, Karthik Dabur. I have completed my bachelor's in computer science, statistics, and electronics, and my master's in statistics. And I have completed my course from MIT Learning, and I have done some projects on the logistic regression, linear regression based on property science data, and some analytical projects on tomato data. Yes. I from the work of knowledge. I have a I worked 6 months in the law and 1 month in charge for average especially the weather and the sound. Along with that, I have he's doing post-graduation and I did my post-graduation in MIT. I did many projects. Your marks are not done right. First one, clear. No, you wanna? Okay, so you have my email ID, guys. You have Sameer's email ID. Yes. Share your CVs on my email ID and Sameer's CV. No. So there is an opening that is for 2 roles. One is for Python developer, one is for data engineer. But right now I just come to data engineer. Python developer I will be sharing. So in a tracker, I think there could be Python developer roles. Don't feel that it is only for data engineering. And when I do that, I graduated in and comes from I was there 5 years. I recently got a
around sentiment analysis of Amazon data. It had around 545,000 records. And if you're specifically determine what would be the feedback in general about the food reviews. So after using two very algorithms, my decision was that people had a positive feedback with respect to Amazon.
Good morning. Myself, I'm from Pune and my hometown is Saran. So in my family, we have people, including me, my sister, and my mother. Master degree in statistics, safety of the data. Right now, I'm studying on machine learning, NLP, and time series, mostly with supervised my hobbies also mostly I like to watch.
We are a family of two fathers who works in outside. My father is an educator. My mother is a business. I recently completed my graduation for learning languages. Apart from this, I have experience and I am a field content also. So when you say machine learning, data analytics, so please cover all this point over here. Right. So basically, what happens is when you say machine learning, client information over there. And sometimes clients have a requirement for machine learning, maybe it's for Python. Just stop asking if it might be there. So don't create a perception client mind that one particular topic is something which is covered. Right. So in Dodo, you can say that a commitment was data science. So that's even better. So when you say regression and all, then keep in mind there are particular topics which have been covered. There's nothing else. So ensure that you are taking the name of a database. That happily fast. You the students about it. Just not saying that they learn SQL and not using the machine about the project that they into data analytics because that's where this skills also matters. All right, getting the point? Yes, sir. Apart from this, I have a experience in content also having skill and creating performing participants. Recently, I worked on a project called the Google Play Store for media education. And the most important thing in that was the efficiency was very good. That was okay, so one more important thing is when you go through the JD, you definitely understand what is the company, right? So when you understand that, you know that if you have done something related to that project, what company will be not okay. That again could be a welcome. Company talking about company research you are talking about. So doesn't make a sense. Like throwing the project just for the sake of throwing something is not good. It is relevant of company which creates the JD, definitely add a value. Do that. Okay, so there is a kind of markup which you need to do. I'm not really trying to take the session of 2 to 3 hours of yours. There are few things, few reasons behind this. I need the gas. I can't take the session. Like this exactly, definitely I the interview would start next week. I will see if I could coordinate all the classes 29, 30, 31, 32 to take one session of something. I will engage within next week. I cannot promise, but I'll try to do it. This would be hours from Monday to Thursday. definitely before the interview with police. But your practice is important. Client doesn't mind you guys being members, but what content you will giving to the client is important. Right? So when you are not talking much, you are not being expensive, you are not being telling clients, you are not telling information about you guys. You need to speak more, you need to speak a very saying something client feels that you are doing right thing. हाँ सर थोड़ा सा है, it is a gap, but मैं कुछ patterns की patterns के हाँ
Many people are very lucky. My father was there, I don't think that is
not required, but क्या होता है कि ये लोग their self introduction is so short कि उसको बढ़ाने के लिए कि ये करवाता हूँ क्या बोलते हैं नाम बोलते हैं पोस्ट क्लियर करना so at least there has to be something to talk or maybe applying और दूसरा ये कि थोड़ा जेडी देख के बोलो whatever you talk ensure that going to the JD you know what is what is so self introduction कुछ भी हो सकता है we 10 people have 10 views about self-introduction. Everyone has their own way of saying it. But the point of self-introduction is client wants to know about you. So the client wants to know about you, whatever you give to the client, you get some kind of a clarity. And so the more you talk, the more information you give to the client, you will get an idea. The background of you saying that you know why you have joined this course being the client. So what you talk is important, but definitely in the session to give you more perspective about this thing. So let's do it next week. I can't commit the time, I can't commit the date, but I'll try to do it. I'll try to for the 29, 30, 1 match. All together. One session. Okay. Actually, 33 batch has 35 people. Yes. So once there was a batch strength which was full, I took this section. So 33 का लिया, 32 का नहीं लिया, it is not good. 29 का नहीं लिया, 30 का नहीं लिया, 31 का नहीं लिया. I don't take otherwise, but I take special guys because that's an idea. What to do. Okay, guys. So you have the JD with you. You have the tracker. Go through. If you feel you are interested, please apply. Okay? Okay. Thanks, guys. Any question? Okay. Next. You can do it. All right. Okay, sir. Thank you.
क्या है जेडी दिखाओ मेरे को एक बॉटल और उसके ऊपर वाली चीज क्या है? गो डिजिटल अबाउट द कंपनी। या गूगल सर्च करो गो डिजिटल क्या कंपनी है, कितनी बड़ी है, कहाँ की है, देखो।
टू 2015 से है सर।
So,
Yes, bro,
Ranjan,
tell me.
so in this Go Digital ka the file that they sent, they said they want education qualifications to be mechanical and engineering and all, but my education qualification is BCom and masters in hospitality, so I wouldn't be eligible, no?
I think so, but this question you should have asked to Sahil, na?
I tried, but he couldn't hear me.
Okay, okay. So उसको एक काम करो, just drop a message to Sahil on the WhatsApp, है ना? So he will respond that. But as far as I see, it is clearly mentioned. They are looking for MSc, BSc, MCA, BTech, IT, CS, electrical, mechanical, civil. So ask him, है ना?
Okay.
Whether you qualify those three requisites. Whether you meet those three requisites.
Okay, sir.
ठीक है guys, है ना? And सब लोग apply करो. अपॉर्चुनिटी तो मेरे को अच्छी दिखती है। एटलीस्ट जो टेक्नोलॉजी जिस पर काम कर रहा है वो अच्छा है। पाइस पार्क सारी चीजें। हालांकि हडूप इज अ टेक्नोलॉजी which is not that widely used, but then PySpark उसने बोला PySpark is a very good skill to have. Normally ये सीखना थोड़ा मुश्किल होता है कहीं बाहर से। तो क्या करें, अब तो पूरा तो सब समय तो यही निकल गया है। गाइस बताओ क्या करें।
Loan amount.
ओके गाइस, सो बताओ क्या करें? व्हाट शुड वी डू टुडे? जो चीज मैंने सोची थी वो तो पता नहीं क्या होगा क्या नहीं होगा। फिर भी चलो ट्राई कर लेते हैं, क्या कहते हो? अपने अपने मन को चेक करके बताओ, मन किस स्थिति में है। कुछ नई दिमाग को ऐसे पिंच कर देने वाली चीज पढ़ने का मन है कैसा? जो झटका दे दे। झटका तो देगी गुरु। और झटका इसलिए देगी बिकॉज ये लास्ट टॉपिक है और ये सबसे मुश्किल ही है सबसे। ठीक है, तो क्या करना है आपस में? 1 मिनट का टाइम लो, डिसाइड करके बताओ एलएसटीएम पे जाना है या कुछ और करना है। जस्ट लेट मी नो। अगर एलएसटीएम पे हम लोग जाते हैं तो कम से कम 2.5 घंटे की कंटिन्यूअस थ्योरी आएगी। ब्रेक पर अभी कुछ पढ़ाया तो है नहीं। अच्छा। अच्छा ठीक है। चलो ठीक है, ब्रेक लो। ठीक है, लेकिन फिर ब्रेक के बाद का भी बता के जाओ, ब्रेक के बाद क्या करने का मन है वो भी बता के जाओ। एलएसटीएम करने का मन है, ठीक है जाओ। टेक का ब्रेक कितने बजे वापस आओगे? हाँ ठीक है, 12:15 12:20 तक आ जाओ, है ना? एंड बी मेंटली प्रिपेयर आफ्टर। एक व्हाट्सएप पे मैसेज डाल दो, बाय 12:15 एवरीवन वुड ज्वाइन बैक। जो क्लास में है जो नहीं है, जिनको लग रहा है आज कुछ पढ़ाई नहीं होगी, एवरीवन शुड गेट टाइम टू लॉग इन, है ना? सो बाय 12:15 विल स्टार्ट विद आवर एलएसटीएम। ठीक है। डिफॉल्ट आंसर तो ये है कि रीड नहीं किया होगा. Okay, so shall we get started, guys? So this is the last topic where any theory is coming. From here onwards, after this topic, कोई theory नहीं आएगी. So RNN. RNN are your, so those who are in online, guys, am I audible? So Kalpesh is saying nahi Arjun. What is this? अच्छा वो किसी और के लिए होगा.
Yes, so you're audible.
Thank you. So RNN stands for your recurrent neural network. Recurrent neural nets. Okay. Now, this RNN are used where there is some kind of time component. Or you can say ordering matters. Ordering matters. There is some time component. So wherever you have built your time series model, probably later on, if you want, you can build your RNNs also. LSTMs also can be used for your time series forecasting. Because there is some time component and ordering matters. So RNNs can also be used for your text analytics. So wherever you have done your NLP, those problems can also be solved using your RNNs, right? So for example, if I say today is Sunday, a Saturday. Okay? So now today is Saturday. So this is a sentence. In this, the ordering matters. You cannot swap today and is. You cannot swap is and Saturday, right? So it is a sentence, or it is an English language or any language. So after one word, then only another word can come. So ordering matters. So for example, let me say if you have this data, for example, and you have number of records till, let's say 1 till 100, and you have your property price data, suppose karo, property price data, then whether you swap this record with this record or whether you swap this record with this record, it doesn't matter, right? Ordering doesn't matter that kaun sa record pehle aaya, kaun sa baad mein aaya. But over here, when you are reading the text, you are reading any sentence, whether it is English, Hindi, Marathi, any language, the ordering will matter. So in those scenarios, your RNNs will come into the picture, or you can say some time component. So, okay, some sequencing, or you can say sequence is important. Sequence is needed. Sequence, okay. That is where your RNNs will come into the picture. Okay. Pardon? Sequence, yes. So for example, after June, only July can come. You cannot stop it. The sequencing matters. So when you are talking in terms of text, then also if you are writing us, so for example, today is Saturday, so you cannot swap today is Saturday, right? Okay. So sequencing is significant, or sequencing matters. So in those scenarios, your RNNs would be needed, right? Now, we will discuss the theory of RNN, but trust me, the nascent form or the vanilla form of RNN or the original RNN is no more used. जो ओरिजिनल RNN था, अब हम उसका यूज नहीं करते. अगर चाहो तो यूज कर सकते हो. I'm not denying that. But why don't we use RNN? Because RNN has a lot of drawbacks. And these drawbacks are very important. So I'll explain you what are the drawbacks. And since RNNs have a drawback, there is another model, that is your LSTM, which stands for your long short-term memory. Long short-term memory. So LSTMs stands for long short-term memory. These are variants of RNN. It is a variant. It is a type of RNN only but it overcomes the problem of initial or the vanilla or the plain RNN. Okay. So there are some drawbacks. Please write down the sentence. There are drawbacks of original RNN or plain RNN, and that is why we use LSTM, long short-term memory. It is a LSTM is nothing but a variant of RNN. So to understand LSTM, first of all, you have to understand RNN, and then only add-on parameter will come through which you can understand your LSTM. तो जब हम theory की बात करेंगे तो theory would be discussed in several parts. One is what is RNN? RNN खुद काम कैसे करता है? Followed by what are the drawbacks of RNN. Then we will move towards LSTM. What is LSTM and how it handles or overcomes the drawback of RNN. Okay. So I would be covering these two things. But I am giving you certain more things for your self-learning. अगर पढ़ा तो अच्छा है, और वैसे मुझे पता है नहीं पढ़ोगे, पर फिर भी मेरा फर्ज बनता है बता देता हूँ. So self-learning के लिए क्या करना है? You need to see another version of LSTM, bidirectional LSTM. Bidirectional LSTM, anyway, I'll cover it up, though it's not part of your syllabus. Bidirectional LSTM. ठीक है? Somewhere I will cover it up. So, or if not, you do your self-study. Then there are GRUs, gated recurrent unit. And then there are some transformer-based models. Transformers-based models. Transformer-based models. And name of those models are BERT and ROBERTA. ROBERTA, तुम लोग को रोबोटा मॉडल या बर्ड के बारे में पता है? नहीं. So basically this is the model which you are using every day. तुम्हें बस पता नहीं है. So these are the state of art model designed by Google. So when you are doing any Google search, background में रोबोटा मॉडल ही यूज हो रहा है, बस पता नहीं है. ठीक है? So every day when you are doing a Google, और Google तुम लोग रोज ही करते हैं लोग, right? So at the back end you are using ROBERTA and ROBERTA. आजकल मेरी लाइफ भी इसी पे गुजर रही है ROBERTA में. तो कभी मूड करेगा तो हम लोग इसको भी डिस्कस करेंगे. But then these are very complex models. First of all, you need to understand transformer. उसके ऊपर BERT फिर ROBERTA आएगा. ठीक है? So these, I think the stable version of these has been introduced just recently, 2020. 2 साल ही हुए BERT and ROBERTA को stable version आएगा. And I think many million years, many million hours of human effort would have gone. So बहुत बड़ी टीम बैठी होगी उसने बनाया होगा. But these are being state of model. But so these are your self-learning bidirectional GRUs and then transformer-based model. ठीक है? So these days many industries, अगर तुम NLP specialist बनना चाह रहे हो तो transformers कैसे काम करते हैं, उसकी theory पता लगा लो. Coding again is not that difficult. You have plug and play kind of features are there. But even if you have to reach anywhere bidirectional GRU transformer, starting तो रहेगी RNN से. Background clear है? क्या करने जा रहे हैं हम लोग? ठीक है? Now since I have said, so can we take a plunge into RNN? Recurrent neural network. First of all, RNNs के एक word से ही start कर लेते हैं. Neural network, you are already aware what is neural, what is network. What do you mean by recurrent? इसका इंग्लिश मीनिंग क्या है? हाँ. वैसे इसमें एक वर्ड यूज किया, क्या यूज किया? एक के बाद एक. हाँ, उसको मैं लिख नहीं सकता, बट एक के बाद एक. उसको मराठी में जो भी बोलते हो, क्या बोलते हैं मराठी में? आजकल मैं मराठी क्लास भी ले रहा हूँ, पढ़ा नहीं रहा हूँ, सीख रहा हूँ. हाँ, क्या? एक अनंत. अच्छा, थोड़ा धीरे धीरे आ जाएगा, कोई दिक्कत नहीं है. ठीक है? रेकरेंट. तो माय नॉलेज इज आल्सो इटरेटिव, स्लोली इट विल बिल्ड. ठीक है? सो रेकरेंट मींस one after the another, and the very same concept. If you remember the English meaning of recurrent, probably you'll see the same thing flowing into your RNN, and that is why this word has been used, recurrent neural network. ठीक है? Okay, so now let's take a deep dive into RNNs. And guys, please थोड़ा अपने mind को prepare रखना because with RNN, I'll try to later on I'll try to combine the LS teams also. But as of now, let's take a deep dive into our RNNs. So what I'll do is मैं एक छोटा सा एक snippet तुम लोग को दिखाता हूँ. These are my notes. ठीक है. Okay. Anyone who would wish to read it? तुम पढ़ो. Please. ऐसे पढ़ो कि सबको सुनाई पड़े. आवाज मेरे लैपटॉप से गुजरनी चाहिए. हाँ.
In other words, RNN was given for considered loop between the neuron where the output of network is feedback and the addition of input to the network. Same output back to itself for subsequent processing. RNN are very useful when from your time that what would be the next feature.
Yes, thank you for reading. Anyone else who would like to read, please? Yes, please.
RNN are class of network. Send output back to them for circuited circuit. RNN are very useful giving us some time-like component. What would be the next?
Okay. कुछ मीनिंग समझ में आता है? किस वर्ड पे ध्यान जाता है तुम लोग का? Circular loops पे ध्यान जाता है. So in other words, RNN, so dynamic temporal behavior is nothing. This is a very heavy word, but meaning is very simple because it means as you iterate, it learns them. It learns. Okay, so nothing more than that. In another word, RNN involve recurrent or the circular loops between the neurons where the output of network is fed back as the additional input. अपना output वापस भेजता है, and that is why it is known as your recurrent circular loop. So it takes a new input and the previous input also. So for example, let's say if you want to so for example, if I say apple is a delicious dash. So if I say Phil, what would be coming over here? And if I say, then I say something like this, I continue the sentence and this dash is good for health. Good for health also. Okay. So I have two blanks, one over here and another over here. Okay. So to fill the first blank, you need to see what has been written before. Otherwise, to nahi kar paoge. So apple is a delicious fruit, probably you say. And then this fruit, यहाँ पे question mark है, यहाँ पे क्या आएगा? Fruit ही आना चाहिए. यहाँ पे this fruit is good for health also. So now you can answer this question after you have answered this one, and this should be sent as an additional feedback. So before, so now do you notice at this point, at point number B, two inputs would be coming. One would be your word this and another would be your this thing. So this will become your new input and this word fruit will become your input from the previous cycle. Okay, समझ में आ रहा है? So every time when you are doing something, you need to take the new input also and the input from the previous time also. Okay. So for example, let me say the October month comes. Just an example I'm saying. October month comes and you are trying to predict the car sales. Now you are seeing that in October month, probably the new input would be that it is a festival month. But the older input would be the number of cars sold in September month, right? So you may say that, okay, cars sold in September month were 10,000 units. So my 10,000 would become a base, and on top of that, I am expecting some 20% of growth. So 20% of growth will change if the September month numbers are different, right? So you also need to look into the previous pehle kya hua, right? So over there, probably LSTMs will come, or I will say RNN will come into the picture. So RNN are very useful when you have some time like component. What would be the next sequence? So sequencing matters. Sequencing is important. You cannot ignore the sequencing. So any language, whether it is English or any language, when you are writing a sentence or words, sequencing will always be important. Chalo, आगे बढ़ते हैं. Okay, now RNNs are fully connected layers. Now, what does fully connected means? Yes, so fully connected means, yes, a very good answer. आज तक तो पढ़ के आई जनता है. So fully connected means each neuron of the previous is connected to all the other neurons of the next. Okay. So it is also known as your kind of your dense. Yeah. Is CNN a fully connected model?
Yes.
Answer is big no. क्यों? Fully connected क्यों है? आखिरी में fully connected आता है. But do you notice CNN is not fully connected? भाई क्यों तुम लोग ने fully connected with confidence बोल दिया? अब तो मेरा confidence डल गया. ठीक है, CNN is not at all fully connected. And the best proof is, remember, in CNN, what is the first layer? Convolution layer. Convolution layer में क्या करते थे हम लोग? समझो वो fully connected क्यों नहीं है? So let's say if this is your original image, okay? Then you have a slider 2x2 का slider. तो तुम slider को यहीं पे तो place करते थे, right? So fully connected कहाँ हुआ? Then you used to slide. At the end, I used to give the fully connected layer or the dense layer, right? जब मैं सारे उनको open up करता था, right? So CNN is not an example of fully connected layer. Okay? It is not example. RNN is. ठीक है. Okay. So RNN is an example of fully connected layer. Okay. यहाँ तक सबको clear है? And then I'll say, but with little difference. But with little difference. Bottle गिर जाएगा. Consider you have one neuron in your layer. अब ध्यान से देखना. Do you see any kind of pattern evolving over there?
output previous step output. Input output of x1 is taken as the input of x2.
Yes. So let's say x1 is a new input. X1 is a new input. Okay. Suppose karo this ways. So remember, I'm saying RNN has some kind of time-like component. So let's say this is the scenario. This is the scenario at time t1. Ye time t1 pe tha. Okay. And forgot about all the other things. Bhul jao ki baki kuch maine banaya. Okay. So this was the input at time t1. X1 is the input at time t1. So for example, you have just started to train the model. You have started to train the model. So you are giving a input. And what is H1? H1 is the output at time t1. And what is H0? H0, since your model is just starting to train, so it would be difficult to say that H0 is a input from the previous time. So you can say that H0 is your default weights. Model train hota hai, to hum ek default weights laga dete hain, right? So it is just some random weights you are passing. But now you come to the time t2. At time t2, this is the new input. And this H1 is the output from previous time or previous time or previous cycle, you can say, yes. And H2 is a new output at time t2. So at any given time, there are two inputs, new input and the output from the previous time. Isko note down karo. In RNN, at any given time, there are two inputs. I repeat, in RNN, at any given time, there are two inputs. New input and the output from the previous time interval acts as an additional input. So in RNN, there are two inputs at any given time, new input and the output from the previous time acts as a additional input. ये बिल्कुल सिंपल है. भविष्य में क्या होने वाला है वो पहले से डिसाइड हो गया है, जो पहले के जो इवेंट हुए. आज के एग्जाम में तुम लोग क्या करोगे वो 4 महीने पहले से उसकी प्रिपरेशन हो रखी है, ठीक है. तो वैसा ही है, कोई भी चीज सडन नहीं है, उसके पीछे की कुछ ना कुछ चीजें चल रही है, ठीक है. Now, similarly, this is what I'll say. What is X3? X3 is a new input at time t3. H3 is a output, or you can say new output at time t3, and H2 is a output, or you can say input from your, output from your time t2, which is acting as a additional input. तो हर समय दो इनपुट आएंगे, एक नया और एक पीछे से जो आ रहा है. So now let me put something. Let me say, using RNN, you are doing some kind of sentiment analysis. You are doing some kind of sentiment analysis. Imagine I'll not say imagine, but recall that, have we seen those type of data set, right? Amazon food review or TripAdvisor or whatever, right? So for example, in that data set, what did you had? Let me just say, you had your text. This text was acting as your X variable. And then you also had your, whether the sentiment is positive or whether the sentiment is negative, this was acting as your Y, correct? So in this text, there would be a sentence, एक sentence होगा पूरा. Suppose करो TripAdvisor पे, you are going and you are saying, I reached the hotel in time, but the rooms were not properly clean and I had to wait for 1 hour before I could do a check-in, right? So this is a input. So suppose मैं एक sentence just लिखता हूँ. You had made a booking and you are giving a review. So when I reached hotel, rooms were not clean and I had to wait. I had to wait for an hour before I could check in. Before I could check in. Okay. Now this would act as your X. This would act as your X. And obviously the person might have given a negative feedback. So he might have marked it as 0 or 1, whatever, right? So now what will happen? Let me again draw the RNN. Slowly, एक step लेते जाएंगे और I will try to build your concept. Now, in RNN, in the previous one, I have said I am taking only 1 neuron, but number of neurons are your hyperparameters, so you can take more than 1 neuron also. You can take more than 1 neuron also. Okay? But for our understanding, so itni cheez clear ho rahi hai? It is not that you will always have 1 neuron. For explanation purpose, I am taking 1 neuron. So now the final decision would be made. Remember, final decision would be made when you read this entire statement as a human being also, let's say. And in this text, what will happen then? There are not only one comment, but many records. ठीक है ना? बहुत सारे records हैं उसमें. ठीक है? And slowly your model will get trained. So what do? You pass this thing. You pass this sentence over here. And you are saying that I will pass 1 word at a time or 2 words at a time. Ajay, remember batch size सबको याद आ रहा है? How many records can I pass at a time? So similarly, you can have a batch also. Instead of passing 1 word at a time, you can pass 5 words, 6 words, 10 words. That is your choice, depending upon how long the statements are, right? So you are saying, as of now, let me say I am passing 3 words or 4 words, whatever. So let's say I am saying I will pass 3 words at a time in my network. So ये 3 words आएंगे. And obviously, remember in RNN sequencing matters, so you will pass the first 3 words. You cannot pass randomly words. You cannot pass the कि मैं नहीं सबसे पहले मैं room pass करूंगा बाद में hotel pass करूंगा, ऐसा नहीं possible होगा, because it is a RNN model sequencing matters. So let me say you pass the first 3 words. So first 3 words would be acting as your input. Okay. So let me say when I reached, ये तुमने pass कर दिया. And then अगर मैं यहाँ पे छोटा सा diagram बनाऊं, so number of neurons in your hidden layer are hyperparameter, and this would be your kind of your output layer. And the output layer will function the same way as your CNS or any other density, right? So it will decide at your output layer, you would be having your softmax function, you would be having your cross entropy, and you would be measuring your loss. Okay, because you have to train your weights also. You have to train your weights also. So now your model starts to train. So तुमने क्या करा? First 3 words are passing, and then you get your H1. But at the starting, since your model is just starting to train, there would be H0 also. These H0 you can imagine as your initial random weights. Okay, initial random weights. Okay, now, so before you can make any decision, this entire sentence should pass. But you are passing 3 words at a time. So over here at H1, what will happen? You would be having your, you would have found your errors or whatever, and you will adjust your weights. Now this additional H1 would be acting. So this would happen at your time T1. फिर additional input आएगा X2. So X2 would be your, let me say, next 3 words. So next 3 words would be passing over here. So let me say hotel, rooms, work. Okay. And then you will have your H2. And the same thing will continue. The same thing will continue. Now, when all these words are passed, so 1, 2, 3, 4, 5, 6, 7, or let me say after around your 8 loops, you will make the decision. You will make the decision. Decision कौन सा decision? Whether it's a negative or a positive sentiment. बराबर. Since you already have a, and remember, as of now, I am not doing the prediction. I am training the model. जब model train होगा, उसके बाद prediction चालू करेंगे. I am training the model. So at the end, you will find your cross entropy, whatever, and you will see how much error you had. So probably now what you will do, you will show, for example, H1, H2, and you have your H3, H4, H5, H6, H7, H8. So now you will start training your model. अब क्या होगा? Model को कैसे train करते हैं? Can I have that one word? Back propagation of errors. Back propagation of errors. Back propagation of errors. So back propagation of errors will happen, and your H8, H7, H6, H5, H4, H3 would be adjusted. Okay. And then probably you will pass the second record. Imagine you had some 1,000 records over here. You will pass second record, you will pass third record, fourth record, whatever. And slowly model will keep on training. Basic idea ये. यहां तक समझ में आ रहा है? अब थोड़ा सा और टेक्निकल कर दें सर. अगर लेमन टर्म्स में समझ में आया तो लेट्स ऐड अ टेक्निकलिटी. चलो एक पैरामीटर और इंट्रोड्यूस कर देते हैं. ठीक है. Let me use a technical words. So again, I am saying number of neurons over here are hyperparameters. So it's not necessary you take one, but whatever happens to one would happen to how many you have. Okay. Now, but for example purpose, I am taking only one. Okay. So again, I am repeating the same statement. At any given time, there are two input. तुम चाहो तो मेरा sentence complete कर सकते हो. ठीक है. At any given time, there are two input. One is your new input and output from the previous time interval. Now, this is what it has happened at time T1. ये T1 पे हुआ है. मैंने अभी purposefully I haven't made the second one. Okay. So now what is H1? So H1, can I say H1 is holding all the information whatever is happened till time T1? Because what is H1? H1 is output at time T1. But then it is not the final output also. ये final तो नहीं है, because a new, similarly your H2 will come, H3 will come, and then at some time you will have a final output. So can I say that H1 till this time it holds the current information? T1 तक क्या हुआ है? That is it holds your current information. So इसके लिए जो टेक्निकल वर्ड होता है वो होता है मेमोरी स्टेट. इट इज द मेमोरी. इसको नोट डाउन कर लो. मेमोरी स्टेट. इट होल्ड्स द करंट इंफॉर्मेशन टिल दिस टाइम. मेमोरी स्टेट. ठीक है. So now input to the hidden layer is H0 and X1, and H0 is the hidden state, and X1 is the password. Okay. So whether it is H0 or H1, these H1 or H0 or H2, they are acting as memory state. They are acting as a memory state, which holds all the information till that point. Which holds all the information till that point. Both H0 and X1 are passed in vector format. They are passed in vector format. What is vector format? Vector format, vector क्या होता है? ठीक है. तुम्हारा आंसर थोड़ा ज्यादा ही कॉम्प्लिकेटेड है, बट इट इज द राइट आंसर. सो वेक्टर फॉर्मेट इज समथिंग लाइक दिस, जिसमें तुम सपोज कर लो कि सिर्फ एक ही कॉलम है. ठीक है ना, जस्ट वन कॉलम. सो दिस इज काइंड ऑफ योर वेक्टर फॉर्मेट. Vector format. So H0 and X1 are passed in. So for example, let me say in example, if you are passing 3 words at a time, if you're passing 3 words at a time, then your X1 would be something like this. Your X1 would be like this. 3 words का एक वेक्टर जाएगा, and obviously words would be represented in numbers. Words would be represented in numbers because machine cannot perform any calculation on text. So words would be represented in numbers, and weights obviously are in numbers. Okay, so now let me say this is your time T2, correct? At time T2, what is the input? Time T2 पे input क्या है? Can I say input is H1 and X2? बराबर? And if you remember, एक चीज तुम लोग को याद आती है जो पहले हम लोग ने नेटवर्क देखा था. So let's say if this was your X1, this was your X2, something like this. Then what was the input over here? Can I say it was input as summation Wi xi plus b?
Yes.
ठीक है. So input यहाँ पे क्या होता है? W1 x1 plus W2 x2 plus bias होता. Correct. We use the very same logic. So what is your H1 and X2? They are input. Okay. So the input over here would be, I will say, or output over here would be something like this. So I'll multiply your weights. So I'll say W, and you can say H2, I'll not say H2 plus H1 plus X2 plus bias. This is nothing but your H2. देखो जरा ध्यान से क्वेश्चन समझती है. So multiply the inputs with your weights and then you add a bias. And this information will pass through your activation function. And if the input is significant, neuron is activated. And then only the output would be. So basically, the same concept will happen over here also, right? So what is the input? Depending upon WH1 plus X2 plus bias. हर एक न्यूरॉन अपने रेलू के साथ आएगा, right? And based upon information is significant or not, it will generate the output. And that output is nothing but your H2. सबको समझ में आ रहा है? So that output would be nothing but your H2. Now this H2 will act as an additional input at your time T3 and you will pass the next set of words. बस ऐसे ट्रेन पर चला जाएगा. Now let's discuss the most important thing. Problem associated with RNNs. Problem associated with RNNs. Basically, दो बड़े issues हैं. Problem associated with RNNs. So basically, there are two main issues with RNN or traditional RNN. One is your vanishing gradient descent. One is your vanishing gradient descent. And another is RNNs do not perform good. Perform good when we have long-term dependency. When we have a long-term dependency. Okay. So these are the two big issues in your RNN. Now let's try understanding the vanishing gradient descent. First of all, tell me what is vanishing gradient descent? Concept wise, how it comes into the RNN, मैं explain कर दूंगा. अगर तुम्हें vanishing gradient descent याद है, तो ये problem बड़ा obvious है. कोई एक जन बोलो please. बताओ कौन बोलना चाह रहा है? Okay, ठीक है. क्या लगता है बहुत अच्छा एक्सप्लेनेशन है? तुम बताओ अच्छा वैष्णव, you were saying you want to explain. Change in y is very less, less. But why? Why does it happen? Why the changes are less? Would you like anyone who would like to explain with an example? Draw करके या कैसे तो? No. But let's say vanishing gradient descent can also happen if you are using ReLU, na? So sigmoid suffer from vanishing gradient descent. That's why we introduce ReLU. But even when we are using ReLU, vanishing gradient descent problem can still occur, right? क्या होती है वो? कैसे समझाओगे सामने वाले? बताओ. Suppose करो तो हमारे पास कॉपी पेन भी मौजूद है. तो कैसे समझाओगे? Slope is becoming kind of fixed, but why? That's what the issue is. क्यों? वही सेम चीज है. उसने स्लोप बोला, तुमने डिसेंट बोला, ग्रेडियंट बोला, बट क्यों छोटी होती जा रही है? Vanishing gradient itself means gradient has vanished. Gradient is nothing but slope. Question is why has it vanished? That is the impact of vanishing gradient descent. Agar vanishing gradient descent will occur, then what is the outcome? But my question is, what causes vanishing gradient descent? Occur क्यों होता है वो? No.
When learning rate is
what causes, let me change my question. What causes vanishing gradient descent? I'm not asking what is the impact of vanishing gradient descent. Impact of vanishing gradient descent is very simple. But what is the reason why vanishing gradient descent happens? और मैंने खूब डिटेल में बताया हुआ इसको. मैं अच्छे से याद है. हाँ, अब तुम सही जा रहे हो. बताओ, एक्सप्लेन करो क्यों अगर होती है. Yes. Yes.
We are expanding the we multiply the differentiation start getting very less. Even if we are using quantity of but there is no change. The point is not.
No. You are telling what happens if vanishing gradient descent occurs. मैं पूछ रहा हूँ कि क्यों होता है. What causes vanishing gradient descent, guys? उसको कुछ ऐसे बताना है. That remember I said. So, for example, if you have a simple network, something like this, let me say. If you have a simple network, something like this, then problem of vanishing gradient descent is very less compared to a network which is very deep. याद आ रहा है? हाइपर पैरामीटर स्पेशली ट्रेन करवाए थे मैंने. एक हाइपर पैरामीटर को लेके करवाया था. वो इसी दिन के लिए करवाया था. Now suppose your network is very deep. You have added many hidden layers. So remember, errors are back propagated. So let me say this is your 1, 2, 3, 4, 5, 6. So let me say W6, W5, W4, W3, W2, W1. So where would the first change come? First change will come at W6. And what is the new weight? New weight is equal to old weight into learning rate into change in weight, which I can say is nothing but dE by dW. Right? Now learning rate, तुम लोगों को खुद पता है, इतनी बार कोड करके देखा है, डिफॉल्ट वैल्यू 0.001. ठीक है. And do you notice जब तुमने point 1 भी करा था तो I said you are seeing that from 0.001 you have gone to 0.1, but it is almost 100%, or it is almost 100 times. And at 0.1 probably your model has missed the optimum point. So learning rate is always less than 1. Right? dE by dW is also less than 1. So it means this number would be much lesser than 1. So now new weight is equal to old weight plus You are adding a number which is less than 1. So, okay, so for example, let me say तुमने 0.5 add कर दिया था. But now the same concept will apply at W5 also. For W5, you will take W6 as your base. सबको ये इक्वेशन याद आ रही है? dy by dx मैंने लिखा था equal to dy by dp. Chain rule word use किया था. dp by dq. At least chain word ही नाम दे देते. dq by whatever you can say dr and dr by whatever. So ये कट जाता था, बराबर? So because errors are back propagated, so errors are direct function of W6. ठीक है, but W5 or W6 is a direct function of W5, and W5 is a direct function of W4. So the first changes will come at W6. They would be more than the changes at W5, and W5 changes would be normally more than at W4. So slowly your changes or change in weight will keep on reducing. And by the time you reach W1, the change is almost nil. And that is why your vanishing gradient descent starts to occur. So errors are back propagated, guys. Errors are back propagated, but model is trained during your forward propagation. Model is trained during your forward propagation. याद आ रहा है? Input इधर से आता है. So if there is no change in input, then probably there should not be any change in W2, W3, W4. जब input ही same है, जब W1 is same, then your model will stop to train. That is the vanishing gradient descent. And what you guys are telling me, what is the problem associated with vanishing gradient descent? Problem associated with vanishing gradient descent, वो सबने सही बताया. That model trains very slowly. Model trains very slowly because weights are changing very slowly. So जो काम 5 iteration में हो सकता है तुम्हें 50 लगे या 500 लगे, right? But model में vanishing gradient descent आया क्यों? Because when you have a very deep network, then the changes at the innermost layer is least. Changes at the innermost layer are these are that causes your vanishing gradient descent. अब देखो, अब किसी को समझ में आ रहा है RNN में vanishing gradient descent क्यों आएगा? सोचो, recurrent है, yes. Now that's a better answer. Acha. Now, see guys, let's apply the, see, I'll draw a small diagram over here. This is the traditional neural networks which you have been working, correct? MLP, multi-layer perceptron. ठीक है. ठीक है. Now, keep this thing in mind. So, will people agree that this model is likely to suffer from vanishing gradient descent? Correct? Because network is very deep. Now, do you notice that probably the same concept is applying in your RNN also? This is your H0, X1, H1, then H1, X2, and then you have your H2. Then you have your X3, H2, H3. And this goes till your, let's say, Hn or Hn minus 1 and Xn and Hn. Correct? And over here, let me say, this is your output. This is the final output, probably you will say. Now, what are these H1, Hn? All these are your weights. And remember, errors are back propagated. So the first of all, the change will come at your Hn minus 1, then Hn minus 2, whatever. And by the time you reach your H1 and H0, gradient would have vanished. समझ में आ रहा है? So they suffer from your vanishing gradient descent. Exactly यही same concept यहाँ पे आता हुआ दिख रहा है. ठीक है? अच्छा, now what is another problem with LSTM? Remember मैंने बोला था ना, sorry, RNN. RNN suffer from two problems. Long term dependency. ये प्रॉब्लम ना इंसानों की भी है इसको याद रखने के लिए मैं तुमसे सिर्फ एक क्वेश्चन पूछता हूँ, इलेक्शंस के टाइम में तुमने कभी ऐसा देखा है जो पार्टीज होती हैं या कह लो जो रूलिंग पार्टी होती है वो बहुत सारे वादे नहीं, वादे तो मतलब होते ही रहते हैं, जब इलेक्शन आता है तो उस टाइम बहुत सारे इनॉग्रेशन होने लगते हैं, क्यों होने लगते हैं, क्यों होते हैं, क्या साइकोलॉजी करना चाह रही है पार्टी तुम्हारे साथ?
लोगों को सोचने पे मजबूर करते हैं। काम किए जिसमें काम किए।
हाँ, ऐसा क्यों बताना चाह रही है, वो कुछ और करना चाह रही है तुम्हारे माइंड से, नोइंगली अननोइंगली होता है। बहुत सारे पुल के उद्घाटन होने लगेंगे, नए नए प्रोजेक्ट्स लॉन्च होने लगेंगे, बाद में वो पूरे होंगे नहीं होंगे, दैट इज डिफरेंट थिंग, लेकिन ऐसा क्यों करते हैं लोग, नॉट ओनली इन इंडिया बट हर जगह, क्यों ऐसा? अटेंशन ग्रैब, चलो न्यूज मिल जाएगी, कुछ और इससे भी ज्यादा कुछ करना चाह रही है वो, है? हाँ, 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 वो चाह रही है कि पिछले 4 साल भूल जाओ, अभी के 2 महीने याद रखो, यही चाह रही है ना, करना तो यही चाह रही है, अदरवाइज ये इनॉग्रेशन 5 साल पहले हो जाता, ठीक है, अगर इनॉग्रेशन ही करना था तो वो क्या चाह रही है? सो बेसिकली वो चाह रही है कि तुम अपनी जो लॉन्ग टर्म चीजें है ना वो भूल जाओ, रीसेंसी पे ध्यान दो, जो रीसेंट फैक्टर है ना, यू जस्ट वोट अकॉर्डिंग टू दैट, पुराने पाप भूल जाओ, पुराना क्या हुआ था भूल जाओ, राइट, यही चीज है। बट कायदे से जब तुम्हें वोट करने जाना चाहिए तो तुम्हें जो लॉन्ग टर्म चीजें उनको भी कंसिडर कर लेना चाहिए, है ना, 5 साल का पूरा एक जगह लिख लो कि हाँ ये था, तब करना चाहिए, बट उसने क्या करा, तुम्हारे माइंड के साथ एक गेम खेला, ठीक है, तो यही सेम प्रॉब्लम आएगी आरएनएन में, that when you want to take a decision, so every time when you are taking a decision, or I'll not say every time but many a times when you are taking a decision, your decision is influenced by the just recent event, बराबर, ठीक है, today is Saturday, why? Because tomorrow was Friday, which is fair enough, you don't need to look into what was, so अगर मुझे को बताना है कि what would be the date tomorrow, what would be the date tomorrow, so I just need to look what is the date today, I don't need to look anything into the past, fair enough. So there are many scenarios where you don't need to look into the past, but then there are many scenarios where you need to look into a far past back, and then only a right decision can be made. So if you don't need to look into very far back and take a decision, then RNNs can also do a very good job. RNNs are also doing a good job, no problem. But if you need to have a long-term dependency, then RNNs will fail. RNNs will fail. You need to use your LSTM. You need to use your LSTM, long short-term memory. So LSTMs का main advantage अच्छा, so इसको वापस इस सेंटेंस को लिख लो एक बार, that RNNs or traditional RNNs are not ideal in handling long-term dependency. ठीक है, they are not good in handling long-term dependency. So if you need to make a decision using looking into past, long past back, then it is not a very, RNS will fail. अच्छा, now let me take an example. So ये example मैंने पहले भी क्लास में लिया, तुम्हारी क्लास में नहीं होगा इसमें. So for example, so कोलाहल में अगर तुम देखोगे उसने एक फ्रांस कंट्री का एग्जांपल लिया. So मैं वैसा ही कुछ लेता हूँ, but I'll take it in a little more in depth. So let me say Japan as a country is aging very fast, and they need a huge, इसको लिखने की जरूरत नहीं है, I'm just reading example, just read it. They need a huge young workforce, population नहीं, workforce जो काम कर सके, ठीक है, labor चाहिए उन्हें, skilled, unskilled, semi-skilled, whatever. They need a huge workforce, and there are many employment opportunities present there. But to work there, you need to know their language. इस मामले में जापान अच्छा है, आज भी इंग्लिश को ज्यादा यूज नहीं करता है, they still rely on their language. So suppose करो एक इंडियन है, उसकी मेंटालिटी क्या होगी? So I am planning to join dash classes. कौन सी क्लास ज्वाइन करना चाहते हो? Japanese language, Japanese classes or whatever, right? Suppose China जाना तो mandatory. So I am planning to join Japanese classes. Okay, चलो यहाँ पे Japanese लिख देते हैं. वैसे ये स्टेटमेंट सच है, अगर तुम लोग जापानीज सीख लो तो चांसेस ऑफ एम्प्लॉयमेंट इन जापान वुड बी वेरी हाई, बट वहां पे काम करना बड़ा मुश्किल है, क्योंकि वहां के लोग सिर्फ काम ही करते रहते हैं, 12-13 घंटे काम करेगा. ठीक है, क्योंकि मैं सिंगापुर में काम कर चुका हूँ, थोड़ा कल्चर वहां से इन्फ्लुएंस होता है, दिन भर डेवलपमेंट करो, रात भर प्रोडक्शन सपोर्ट करते रहो, ठीक है, वो अलग चीज है. बट यहाँ पे आओ. अच्छा, नाउ टेल मी हाउ मच टाइम डिड यू टुक टू आंसर दिस क्वेश्चन? कितना टाइम लगा? फ्रैक्शन ऑफ अ सेकंड, जैसे पढ़ा वैसे आंसर कर दिया. बट कैसे? So will you guys agree that this sentence, this Japanese answer which you gave, the answer is right? ये आंसर सही दिया है तुम लोगों ने. But was this answer given based upon reading these 4 sentences or based upon your some previous knowledge? कुछ previous knowledge थी जो बचपन से पढ़ते आ रहा है, उसका यूज करा तुमने? अगर नहीं तो शायद मुश्किल हो जाता. सपोज करो तुम्हें इंग्लिश लैंग्वेज आती ही नहीं थी, तो क्या करते? अभी भी बता पाते क्या? नहीं. So whatever answer you have given, you have not given just by reading these 4 sentences. You have some previous knowledge. That is okay. You have given it one thing. Now when you are training the machine, machine doesn't have any previous knowledge. उसके लिए तो पूरी चीज नहीं है. So अब you have used this word Japanese very easily. But ये word कितनी बार आया है इस डॉक्यूमेंट में? How many times has it occurred? Only once. Before you answered Japanese, it was used only once. So it means if machine has to answer this question, then it has to look somewhere in back. Usko after Japan, how many words have been used? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39. So it means for machine, you need to look 39 words back and then only you can answer. और जरा ध्यान से देखो, मैंने ना हर जगह after using Japan, I have just used word there, there. Right. So now do you notice there is a, if you want to answer this question, there is a, can I say there is a long-term dependency? आज क्या होने वाला है वो बहुत पीछे जाके देखना पड़ेगा, then only you can answer. So in these scenarios, RNNs are performing poorly or they are not good, but LSTMs are good. ठीक है, सबको समझ में आ रहा है लॉन्ग टर्म डिपेंडेंसी का मतलब क्या है? ठीक है, टेक अ मिनट, व्हाटएवर नोट्स यू वांट टू मेक, देन विल मूव एंड लेटर ऑन विल सी कि LSTM इन प्रॉब्लम में कैसे आंसर करते हैं. Okay, so आगे बढ़े. Now suppose करो यही same sentence में continue करता हूँ. I continue the very same thing and I write something over here. So Japan is a country which is aging very fast and then they need a huge labor force and that is why I want to join whatever. Okay, now suppose now. So you are reading an article, let me say in a newspaper, and the article continues. The next sentences come over here. Okay. I'll say, despite of less labor force, this country is still a very large economy and highly industrialized nation. Highly industrialized nation, and it has pioneered or it has pioneered in automobile. एक टाइम में ऑटोमोबाइल का ये जाइंट हुआ करता था, आज भी है ना, बट अब शायद उतना नहीं, और चीजें भी आ गई हैं. बट if you take any major automobiles, Suzuki and Toyota, all these are coming from Japan also, and lot many practices like your just in time, Kaizen and Six Sigma, ये सारे principle वहीं जापान से निकल के दुनिया में फैले. Despite of less labor force and the country is still working, still is a very large economy and highly industrialized nation as India, and in automobiles and let me say manufacturing, but it is facing huge competition from Asian countries like your I can say your, let me say, अगर एशियन में वो नहीं आते तो एशियन वर्ड हटा देते हैं. Other countries like China छोड़ देते हैं, चाइना तो खैर सबका बाप है. Let me say from your South Korea, and then your, let me say, Philippines and Taiwan, and let me say एक और country में बोलना चाह रहा हूँ, नाम याद नहीं आ रहा, Indonesia. ठीक है, it is facing huge competition from these countries because labor cost is less. ठीक है, labor cost is less. ठीक है, so keeping that thing in mind, it is expected to grow by 2%. It is expected to grow 2% in GDP, whatever, right? And then probably you start writing something about GDP or whatever, right? So now you say that GDP is your gross domestic product. It is calculated by how much you are, the total income is divided by the population, whatever. Okay. Now, do you notice one thing, that at the starting, when the document started, I was talking about the population. But soon or later on, probably I am not talking much about the population, but I'm talking more about the economic conditions. Topic change hota hua dikhta hai. Topic change hota hua dikhta hai. From population to labor force, and then probably manufacturing, automobile, and then what would be the future growth of Japan, right? Now, and then the document continues. You are reading, some more words are being added. Then you start talking about GDP. You start comparing the GDP of Japan with several other countries and what are the advantages and problems those countries are facing, whatever, right? The document continues. Now, so for example, if I say the GDP of its GDP is some, let me say, $3.5 trillion, and let me say put a question mark over there, $1 trillion, right? So probably you can say that this word would be trillion based upon your knowledge, right? Now, when you want to answer this question, do you need to look into the far back? What is the aging of the population, or whether the population of Japan is aging very fast? When you want to say that over here the word would be used as your trillion, then probably I don't need to look very far back. I don't need to, or let me add a word, something like this, which will give you more clarity. Just give me a second. So I talked about GDP, and then you say GDPs are measured in USD trillion. Okay. And Japan is expected GDP of Japan for year 2022 is around 3.5, and then you have a question mark. Okay. So probably to answer this question, I can just refer a very recent word, trillion, right? I don't need to look into what was the age of the population, that whether the Japan is suffering from the problem of aging, or they need a skilled labor or whatever, right? So now over here, what is happening? So at the starting, the topic was your age problem, labor force. Then it moved towards your manufacturing. In manufacturing, I mentioned your auto sector and whatever, right? And then I'm comparing with some other countries. And then I'm coming towards our GDP. Topic ka shift and drift, dekhte, right? So when you're talking about GDP, you don't need to look into the issues of your, whether it is facing the problem of aging. So what does it mean? It means when you want to answer this question, your focus should be more on the recent past compared to a long-term dependency. Recently क्या हुआ है वहां पे हमें देखना है. The recent thing would always be very important. Recent thing हमेशा important ही होगी, but not every time your past would be as important. So what does it mean? It means you need to flush out some past information. बराबर? Past की कुछ information तो हटा दो. You need to flush out some past information, but also carry some past information. ऐसा तो नहीं ना कि पूरी की पूरी पास्ट को हटा दोगे, पास्ट के वेटेज को कम कर दो. So for example, let me say you are watching a movie. So whatever happens in the next scene has something to do with the previous scene, or 2 minutes before or 3 minutes before. It not always it has to do what has happened 40 minutes before. But कभी-कभी हो सकता है कि that sudden flashback आए कि हाँ बचपन में ऐसा दिख रहा था, बचपन का कोई इवेंट याद आ गया. So you may need to carry some information from the past, but not always. So you cannot totally flush out the information. You may not always carry the entire information. So elections में यही हो रहा है, वो तुम्हारे past को मिटा देता है, सिर्फ करंट से लोड कर देता है. नेक्स्ट टाइम जब जाना तो ये याद रखना, ठीक है. सो RNNs, मैंने क्या बोला, that RNNs are also kind of a neural network, and neural networks suffer from the same problem which human beings suffer. ठीक है. Our neural network should be used where humans have advantage. ठीक है. So you need to flush out some past information, but also need to carry some past information. अच्छा, before I go into anything, LSTM वैसे तो मैं तुम्हें 2 लाइन में समझा सकता हूँ अगर लेमन टर्म्स में समझो. Now suppose if you do not learn any new thing today, ठीक है, plus if you do not forget any new thing today. Hello. 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 Okay. Then your today's knowledge and yesterday's knowledge is same. बताओ, अगर कुछ नया सीखे नहीं, पुराना भूले नहीं, तो जो ऐसे कल से वैसे याद रहोगे. बराबर. सपोज करो तुम सोते रहे, ठीक है, तो कुछ नया सीखे नहीं, और माइंड में चलो कि तुम्हें योर माइंड इज अंडर योर कंट्रोल, जब तक तुम चाहोगे नहीं तो कुछ भूलोगे भी नहीं. So you will then, so if you do not learn any new thing and if you do not forget any new thing, तो तुम्हारी कल की और आज की नॉलेज सेम. बट टू लर्न समथिंग न्यू, कुछ भूलना भी जरूरी है, ठीक है. टू लर्न समथिंग न्यू, some past information has to be flushed out. अब मान लो किसी दोस्त से थोड़ी लड़ाई हो गई, बट वापस दोस्ती करनी, आगे बढ़ना, तो थोड़ा भूलना पड़ेगा, मानते हो, है ना? ज्यादा पुराने चीजों को याद रखोगे तो रात में अच्छी नींद नहीं आएगी, है ना, कि उसने ये कहा था, बिल्कुल दिमाग खराब हो गया, है ना? तो वही सारी लाइफ के जो कंसेप्ट है भाई यहाँ पे भी लग जा रहा है, ठीक है? टू लर्न समथिंग न्यू, सम पास्ट इंफॉर्मेशन हैज टू बी फ्लश्ड आउट। बस एग्जैक्टली यही सेम कंसेप्ट पे एलएसटीएम काम करेगा, बट टेक्निकल थिंग्स में उसमें फिर गेट्स आएंगे। ओनली थिंग इज हाउ टू फ्लश आउट द इंफॉर्मेशन एंड हाउ टू ऐड द न्यू इंफॉर्मेशन। So whenever you see, so remember now, connect this same concept to this problem. So over here, when you want to make a decision over here, you don't need to look into the very past thing. You need to look into the recent thing. The recent thing would always be important, but something from past has to be carried. And if you think that that information is slowly not that meaningful, you keep on reducing the weightage. You cannot flush out totally, and probably you cannot keep it totally. Weightage धीरे धीरे कम करते जाओ, ठीक है ना? So inherent concept of LSTM का यही, ठीक है? So it can handle your long-term dependency, ठीक है? And why it can handle the long-term dependency? Because it will flush out the information which is not important, and it will carry the information which is important, ठीक है? सारी की सारी चीजों को ले, अब सपोज करो अगर मैं बोलूं कि नेक्स्ट मूवी सीन में क्या होने वाला है, and you have already seen the movie for 1 hour, and if you say I want to predict what is happening at the 1 hour 1 minute, and I will do the whole analysis what has happened in last 1 hour, then time taken would be very much. Next 1 minute में क्या होने वाला है, you can just look into the last 5 minutes, है ना? गोली लगी तो मरने वाला है, ठीक है? ये क्यों देखना कि वो कब पैदा हुआ था, ठीक है ना? So somewhere some information has to be flushed and some has to be kept, ठीक है ना? So that is the inherent concept of your LSTMs. अब प्लीज वाला एक आर्टिकल निकालो, कोलैब का मैंने एक भेजा था ना, अब वापस वो आर्टिकल ओपन करो और जरा से पढ़ने की कोशिश करो। क्या हुआ, क्या हो गया चैट पे? अच्छा, ये सब जो थ्योरी है ना एलएसटीएम की और इसकी, इसमें सिर्फ तुम्हें क्या क्या याद रखना है। आई एम नॉट एक्सपेक्टिंग कि कोई तुमसे एलएसटीएम की या आरएनएन की पूरी थ्योरी पूछेगा, राइट? ट्राई रिमेम्बरिंग दोज थिंग्स व्हिच कैन बी आस्क्ड इन इंटरव्यू। सो व्हाट इज द ड्रॉबैक ऑफ आरएनएन, और व्हाई आरएनएन सफर फ्रॉम वैनिशिंग ग्रेडिएंट डिसेंट, ठीक है ना? और व्हाट आर इन टू इनपुट्स एट एनी गिवन पॉइंट, ये क्वेश्चन सीधा दो, ठीक है? तुम लोग यहाँ पे जाओगे, वहां पे तुम लोग को काम करना है, तुम्हें किसी को थ्योरी एक्सप्लेन नहीं करनी, ठीक है? मॉडल ही बनाना होगा, तो यू हैव टू क्रिएट अ मॉडल, राइट? You don't have to do this thing. Okay, so remember what type of things can be asked. अच्छा, अब लिंक शेयर हो रहे हैं, इसका मतलब पढ़ाई तो हुई नहीं होगी, ठीक है? चलो आओ, कौन पढ़ना चाहेगा प्लीज स्टार्ट करो क्वेश्चन पढ़ना। कौन है शुभम? पढ़ो, मिस्टर 8 लाख पढ़िए। जोर से पढ़ो। यस। Yes, एक second. So do you notice the same thing probably I have been telling you also? So humans don't start thinking from the scratch every second, right? So when you are reading this thing, you already know ABCD. ये sentence को पढ़ने से पहले तुम ABCD सीखते तो नहीं आते? That is the knowledge which you are carrying from your childhood. So humans don't start thinking from scratch every second. As you read this essay, you understand each word based upon your understanding of the previous word. If today you are able to understand or you would be able to understand RNN, then it has something to do with what started 4 weeks back. जब मैंने neural network समझाना start किया था, right? So as you read this essay, you understand each word based upon your understanding of the previous word. You don't throw away everything and you start thinking from scratch again. Okay? Your thoughts are persistent. So for reading and understanding this article, probably you need some understanding of understanding of neural network, but probably you don't need the understanding of some chemistry formula. वो knowledge का हमें use नहीं करना, उसको हटा दिया. Just knowledge का use करना है, उसको persist रखता. So there is lot of information, but every time you don't need all the information. You need some part of it, and that is the main thing. Please continue ahead. So traditional neural networks can't do this. So traditional neural network means he is referring to your RNN. So RNNs cannot do this thing. And it seems like a major shortcoming. So basically they cannot decide which information to keep and which information to be flushed out. For example, imagine you want to classify what kind of event is happening at every point in a movie. It's unclear how traditional neural network would use its reasoning about previous events in the film to inform later ones. Yeah, please continue. Persist. फिर से पढ़ो. Recommend. ठीक है. In recurrent neural networks address this issue. There are networks with loops in them. ये diagram कुछ अलग है क्या जो मैंने बताया? ये same है. This is the same diagram. Only thing is this is the जिसने इसको circular में दिखाया है, मैंने rolled up version दिखाया तुम्हें. ठीक है ना? This is the same diagram. ठीक है. So can you notice the information is going back, right? So now this diagram and this below diagram, देख रहे हो same diagram है. So if you open it up or if you flatten it up, this circular loop would look something like this. Okay, ये समझ में आ रहा है? In above diagram, a chunk of neural network A looks at the same input xt and outputs the value. These loops make recurrent neural networks some kind of mysterious, right? So whether you take the first diagram or whether you take the second one, these are same. A recurrent neural network can be thought of a multiple copies of the same network, each passing a message to a successor. So whatever is going to happen at the next time, you need to look something what has happened in past. Consider what happens if we unroll the loop. ठीक है? The chain-like nature reveals that recurrent neural networks are intimately related to sequence and list. They are natural architecture of neural network to use for such data. So remember, I have already said that RNNs can be used when you have some time-like component, and they certainly are used. In last few years, they have incredible success applying RNNs to a variety of problems like your speech recognition, language modeling, translation, image captioning. Image captioning क्या होता है? Image देख के बताना कि image किस चीज से related है. So image captioning as in, let's say you see an image, car is running, so the caption would be car is moving or whatever, right? The list goes on. I will discuss the amazing feats which was discussed. So the unreasonable effectiveness of recurrent neural network, but they really are pretty amazing. Essential to these success is the use of LSTM. So what is LSTM? Long short-term memory. These are the variants of RNN. A very special kind of recurrent neural network which works for many tasks much better than the standard version. Almost all existing results based on recurrent neural networks are achieved with them. It is these LSTMs that we will explore this. So RNNs जो काम करते हैं same काम LSTMs करती हैं but with an add-on. They do not suffer or they do not have those problems which traditional RNNs are having. And what are the two traditional problems? Vanishing gradient descent, long-term dependency. अब यहां से तुम लोग जरा वापस पढ़ो, 5 मिनट का टाइम लो, जरा पढ़ो, देखो क्या समझता है, फिर मैं समझाता हूँ. स्लो स्टेप्स लेते जाओ, है ना, शाम करके धीरे धीरे पीते जाओ पानी. थोड़ा नीचे तक आर्टिकल पढ़ो, देखो क्या समझता है LSTM नेटवर्क. फिर LSTM नेटवर्क को पढ़ो, ठीक है. और when you are reading LSTM, keep in mind whatever theory we have discussed. So how can it handle the long term dependency? अपने दिमाग को जरा जोर डालो, फिर देखो. क्या लगता है, कुछ समझ में आ रहा है? ये डायग्राम ना, tan H is nothing but you consider it as a ring. ठीक है, अच्छा ये वाले हाँ, नहीं ये वाले डायग्राम पे तो अगर हम बैठे हैं, तुमने थोड़ा दिमाग लगाओ, फिर तो मैंने तो हर चीज समझा दी, बट मैं चाहता हूँ कि तुम स्लोली बट स्टडली वहां पे पहुंच जाओ, है ना, विद ऑल द लेयर्स इन योर माइंड. ओके, नाउ लेट्स कैन वी स्टार्ट फ्रॉम हियर. वैसे टाइम थोड़ा कम बचा है. लेट्स जस्ट इंट्रोड्यूस एंड देन probably we'll continue with our theory tomorrow also. Long short-term memory, usually called LSTMs, are the special kind of RNN. So now you already understand that RNNs have a very inherent drawback. So normally we don't use vanilla RNNs. We use our LSTM. RNN का मतलब ही LSTM हो गया. वैसे अब LSTMs के भी बाप आ गए हैं, तो हम लोग शायद LSTMs भी बहुत से लोग यूज नहीं करते. They directly go for GRUs or bidirectionals. But let's focus over here. LSTMs are a special kind of RNN capable of learning long-term dependency. What is the major advantage? Long-term dependency. ठीक है. They were introduced by, या प्रोनाउंस करो कौन है ये, ठीक है, हॉक्शे एंड श्रम्बर्गर. नाम से ऐसा लग रहा है कोई जर्मन है. एंड वर रिफाइंड, जर्मनी वाला है, देख लेना इसके कुछ तो होगा, इसका विकिपीडिया जर्मन है, ठीक है. 1997, सो रिसेंटली हुआ. एंड पॉपुलराइज्ड बाय 1997 में तो डिस्कवर हुआ है. बाय द टाइम इट वाज पॉपुलराइज्ड और व्हाटएवर इट माइट हैव टेकन, ये क्या हो गया, जब मैंने शायद क्लिक कर दिया, ठीक है ना, अच्छा वहां पे क्लिक करने का ऑप्शन है आई थिंक. अच्छा हाँ, वो बोल रहा है. एंड वर रिफाइंड एंड पॉपुलराइज्ड बाय मेनी पीपल इन द फॉलोइंग वर्क. They work tremendously, work on large variety of डिस्कशन नहीं करना भाई, ठीक है. नहीं, इसके कुछ तो भी आया था ना, ठीक है. LSTMs are expectedly designed to avoid the long-term dependency problem. Remembering information for long-term period is practically that their default behavior and not something they struggle to learn. इसको याद रखना. LSTMs are designed in such a way that they can remember the long-term information. जैसे कुछ लोग होते हैं ना, बिल्कुल पुरानी चीज याद रखी रही, फिर एक दिन बताया नहीं उस दिन तुमने ऐसा किया था, वैसा वाला है, ठीक है ना। सो रिमेम्बरिंग इंफॉर्मेशन फॉर लॉन्ग पीरियड ऑफ टाइम is practically their default behavior, ठीक है, and not something they struggle to learn. All recurrent neural networks have a form of chain of repeating models. So LSTMs are nothing but a variant of RNN. Now, do you notice that this diagram which you are seeing over here, for time being, if you ignore tan H, then it is almost similar to this diagram. It is similar to this diagram. At any given time, do you notice two inputs are coming? इसको अगर मैं स्निपेट लेके करूं, पेंट विंडो दिखता है, मैं एंटायर स्क्रीन शेयर करता हूं. नाउ डू यू नोटिस दिस थिंग? सो लेट if you say this thing at time t naught, then this is at t1, this is your t2 probably. So at any time, do you notice this is the new input and this is the input from previous time. This is the input from previous time. That's it. Okay. Okay. So LSTMs also have a chain-like structure, but the repeating module has a different structure. Okay. Instead of having a single neural network layer, there are 4 interacting in a very special way. Okay. Now this above diagram is of your simple RNN and the below one is of your LSTM. और LSTM के अंदर में ये अंदर की चीजें आ गई हैं. So you have a sigmoid, you have a tan H, you have this thing. So don't worry about the detail of what is going on. We will talk about LSTM diagram step by step later, but for now, let's try to get comfortable with the notations which we would be using. So in this above diagram, do you notice somewhere they have used circle, somewhere they have used the squares, box, somewhere they have used the cross function, kahin pe tan H likha hai, right? So neural network layer, point-wise operation, vector transfer, concatenation, and then you have your copy. In the above diagram, each line carries the entire vector. I have already told you what this vector is. From the output of one node to the input of another. The pink circles represent point-wise operation. The pink circles are representing your point-wise operation. So we'll see what point-wise operation means. Like vector addition, while the yellow boxes are learned neural network layer. Yellow boxes दिख रहे हैं इसमें. These are your neural network layers. Lines merging denote concatenation. जो lines merge कर रहे हैं. So for example, ये line. The core idea behind LSTM. अब अभी देखो मैंने तुम्हें एक चीज बताई थी ना, अगर कुछ नया सीखो नहीं और कुछ पुराना भूलो नहीं तो क्या होगा? वही सेम चीज वो तुम्हें टेक्निकली बताने वाला है जो मैंने तुम्हें गीता का ज्ञान एक लाइन में दिया है. सपोज करो दिस इज योर x1, this is your h1, or let me say this is your xn, this is your hn, and this is your hn minus 1. So if xn is same as xn minus 1 and hn minus 1 is same as your hn minus 2, okay, then there won't be any new hn. Suppose karo this is your neuron, okay, this is a new, this is your old information, barabar? This is your old information. So this is new information and this is your output, barabar? So if you cut out the new and take the complete old, then output would be equivalent to your old, बराबर? कुछ नया सीखा नहीं, कुछ पुराना फ्लैश आउट नहीं किया, then your output would be same as your input. Almost same function पे काम करेगा ये, ठीक है? Now the key to the LSTM is your cell state, a horizontal line running through the top of the diagram. वैसे पता है ये diagram ना जिसने अपना क्रिएट किया रिसर्च के टाइम में उसने डायग्राम क्रिएट किया, अगर उसको पता होता कि इस डायग्राम का यूज करके लोग पढ़ाने वाले तो शायद और अच्छा क्रिएट करना चाहिए था, ठीक है। थोड़ा कंफ्यूज भी करता है एट द स्टार्टिंग। The key to the LSTM is the cell state, the horizontal line running to the top of the diagram. The cell state acts like a conveyor belt. ये वर्ड याद कर दो अगर कोई पूछता भी है ना, तो cell state acts like a conveyor belt. बहुत सारे मैकेनिकल वाले लोग हैं, कॉन्वेयर बेल्ट क्या होता है? जिसपे प्रोडक्ट्स लगातार आते रहते हैं एंड दे पास कीप ऑन मूविंग। सो फॉर एग्जांपल सब, हाँ उसको तो खैर कॉन्वेयर बेल्ट भी कह सकते हो, बट लेट मी से कॉन्वेयर बेल्ट कुछ ऐसे होगा, एक गियर होगा और एक गियर यहाँ पे होगा, ठीक है। दीज गियर्स विल कीप ऑन रोटेटिंग एंड यहाँ पे एक पट्टा होगा एंड द प्रोडक्ट्स विल कीप ऑन कमिंग ओवर हियर, राइट। सो लेट्स से यू आर डूइंग द पैकेजिंग ऑफ अ बॉटल, तो क्या होगा, लेट्स से एक रॉ बॉटल यहाँ पे आई, सो एट दिस पॉइंट probably you may add a cap, at this point you may add a sticker, and then क्या होगा, at the end it will go to your destination. Just be box में practice है. So conveyor belt होगा. So what conveyor belt का main concept क्या है? It just keeps moving, move करती रहती है, and new inputs keep on coming and the old products keep on getting removed. Same concept. The cell state is like a conveyor belt. It runs straight down the entire chain with only some minor linear interaction. It is very easy for information to just flow along it unchanged. ठीक है, the LSTMs. अब बस ये डायग्राम, ये एक लाइन देखो और ये लाइन मैं तुम्हें ऑलरेडी समझा चुका हूं, देखो, just see this one line. So what is he saying? He is saying the key to LSTM is a cell state horizontal line passing to the top of the diagram. So basically he is referring to this line. He is referring to this line. He is referring to this horizontal line. This horizontal line which is acting like your conveyor belt. Conveyor belt. The cell state is like your conveyor belt. And remember, cell state हमने भी थोड़ी देर पहले डिस्कस करा था. It holds the information till this point. It is like a hidden state. It holds the information till this point, right? It runs straight through the entire chain with only some minor linear interaction. So on your conveyor belt, what happens? On conveyor belt also some products come and some products move out. ऐसा तो है नहीं, जो बॉटल पहले है, जो ऑब्जेक्ट पहले है वो हमेशा रहेगा. They will come and then they will be moved out. And then new will again come. Now, do you notice CT plus 1? Consider karo, this is your human brain. Remember, neurons are nothing but they function like your human brain. Consider karo, ye tumhara brain hai or conveyor belt hai. Now, what is CT minus 1? CT minus 1 is the information at time. Information at time T minus 1. Now, do you notice this cross? This cross is like your flushing out the information. You flush out some information. And what is this plus? You add some information. Barabar? So amount of information you flush out and amount of information you add, it will make the difference between your CT minus 1 and CT. Agar suppose karo you don't flush anything and you don't add anything, then CT minus 1 would be equivalent to CT. Suppose you are passing the same sentence which has been passed just now, then there is nothing to flush out, there is nothing to add. So this is where you are flushing out the information. And do you notice a plus sign? You are adding some information. You flush some and you add some, and that makes a difference between your CT minus 1 and CT. अगर ये एक लाइन समझ में आ गई तो समझ लो LSTM अब समझ में आ गया. Only thing is how to decide which information to flush and how to decide which information to be added. वो next step में करोगे, ठीक है? But ये idea सब तो समझ में आ रहा है. कुछ भूल जाओ, कुछ नया सीखो तो change आ जाएगा. Otherwise it will remain same, right? So based upon, let me say, based upon what information or what old information you flushed and what new info you added makes the difference between CT -1 and CT. आज का ऑफिशियल क्लास टाइमिंग कितने बजे तक है? कितने बजे तक है? 3:30 ना, तो फिर कंटिन्यू करो। मुझे लगा 2:30 बजे तक। So it will make the difference between your CT -1 and CT. इतना समझ में आ रहा है? एक स्टेप और ले ले, माइंड है सबका साथ पे? है? नहीं है? यार अब इतने दिन क्लास लेने के बाद तुम लोग अपने मन की बात खुल के बता सकते हो। ऐसा कुछ नहीं कि हाँ सर बोल रहे हैं तो नहीं चलो पढ़ लेते हैं, ऐसा कुछ नहीं है। ठीक है, अब बिल्कुल आखिरी की स्टेजेस में आ गए। ठीक है, चलो हल्का सा कंटिन्यू करते हैं 2 मिनट और, एंड देन प्रोबब्ली आई लैंड द सेशन। आई डोंट वांट टू ओवरबर्डन योर माइंड, अदरवाइज पूरी पुरानी इंफॉर्मेशन तुमने फ्लश कर दी तो दिक्कत आएगी। ठीक है, द LSTMs does have the ability to remove or add information. देखो वही सेम चीज बोल रहा है, to the cell state carefully regulated by the structures called gate. Now that I have seen, we understand that I need to flush out something, I need to add something. Only thing is kaise. So I will use the gates. Logic gates पढ़े, OR gate, NOR gate, XOR gate, वही gates इसमें आते हैं। ठीक है, उतना डीप में तो नहीं है। So gates are the way to optionally let information pass through. They are composed out of sigmoid neural net layer and point-wise multiplication operation. So the question is how to flush out and how to add. Answer is your gates, and the gates are designed using your sigmoid. So remember, sigmoid can also act as your flushing out. So let's say if the value is below 0.5, you flush it out. Otherwise, you add it. Okay. The sigmoid layer outputs number between 0 and 1. This is a very obvious thing. The values are between 0 and 1, describing how much the each component should be let through, and the value of 0 means nothing should pass, while the value of 1 means everything should pass. So remember, मैंने एक चीज क्या बोली थी, that not every time you can't delete the entire past information. पूरा past information मिटाना भी ठीक नहीं है, but it is not good to carry the entire past information also. So for example, what is happening today, you may need to look into some yesterday or day before yesterday or 3 days back, and then slowly you will keep on reducing the weightage, right? So remember, in your sigmoid you get the answers from 0 to 1. And sigmoid gives your answer in probability. Probability can be anything between your 0 to 1. So if the lower is the probability, so probability you can take as your weightage. So weightage कम करता चला जाएगा, right? So whichever information is needed. A value of 0 means let nothing pass through, while the value of 1 means let everything through. And LSTM has 3 of these gates to protect and control the cell state. Basically, LSTM तो अब actually deep वाला LSTM तब चालू हो रहा है। ठीक है, जो अपर लेवल पे जो समझना है वो हमने समझ लिया यहाँ पे। ठीक है, अब ये बताता है दिस इज योर फॉरगेट गेट, इनपुट गेट। सो बेसिकली देयर आर 4 सेल्स, फॉरगेट गेट, इनपुट गेट, एंड एक हिडन गेट होता है और एक आउटपुट होता है। ठीक है, सो एनीवे हम लोग कल यहाँ से करेंगे। ठीक है, ट्राई, सो वन माय सजेशन इज ट्राई रीडिंग द आर्टिकल। इसके नीचे का आर्टिकल पढ़ो, यू ऑलरेडी हैव सम इंफॉर्मेशन व्हिच यू हैव गॉट टुडे। सो व्हाइल रीडिंग दिस आर्टिकल डोंट फ्लश आउट दैट इंफॉर्मेशन। ठीक है, उसको वेटेज 1 के साथ देके पढ़ना, तो ये थोड़ा सा ज्यादा। ठीक है, एंड देन अगेन आई विल ट्राई टू एक्सप्लेन कि ये हो क्या रहा है। ये इक्वेशन देखने में जितने बड़े और कॉम्प्लिकेटेड है, ट्रस्ट मी उतना ही सिंपल है, कुछ खास नहीं हो रहा। देख रहे हो यहाँ पे भी उसने सेम फॉर्मूला लगाया है, समेशन ऑफ WI XI + B। ओनली थिंग इज इंस्टेड ऑफ यूजिंग ReLU as यूज सिग्मॉइड, बस खत्म। दिखने में भारी भरकम है, ठीक है एक्चुअली सिंपल। ठीक है, ये इक्वेशन भी दिखने में बहुत बड़ी लग रही है, लेकिन ध्यान से देखोगे तो वैसे बहुत सिंपल सी है। एक काइंड ऑफ लीनियर इक्वेशन आती हुई दिख रही है। ठीक है, CT इंटू FT क्या है, वेटेज हो गया, CT -1, IT अगेन काइंड ऑफ वेटेज है, और CT इज योर मीन फॉर्मेशन, बस। ठीक है, व्हाट इज tan H? tan H इज नथिंग लाइक योर सिग्मॉइड, एक्टिवेशन फंक्शन ही है सिग्मा। ठीक है, ओनली थिंग इज सिग्मॉइड इज फ्रॉम 0 to 1, इट इज फ्रॉम -1 to +1। ठीक है ना। बस यहां तक पढ़ो, वेरिएंट्स ऑफ लॉन्ग शॉर्ट टर्म मेमोरी की कोई ज्यादा जरूरत नहीं है, ठीक है, ठीक है, प्लीज रीड इट एंड टुमारो वी मीट एट 8:30 एंड देन विल डिस्कस। अच्छा गांधी जयंती है कल, नहीं मतलब मंडे की बात करें, मंडे को है ना, मंडे को करेंगे, 1 घंटे की थोड़ी बची है और कोडिंग में ज्यादा टाइम नहीं लगेगा, कोडिंग वुड बी अराउंड 1 आवर, ठीक है, तो मंडे वी विल डू इट, ठीक है, ठीक है गाइस, तो गांधी जयंती मनाओ, है ना, बापू जी का बर्थडे है, सेलिब्रेटेड, केक वेक लाओ, कट करो, ठीक है गाइस, सो विद दिस आई विल एंड द सेशन, थैंक यू फॉर